Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
I'm Lily. For math homework, help call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
Nicely done, Lily. So where do you go to school?
At Panama.
All right, so at Panama. And you are in?
6th grade.
6th grade. You've been there for 7 years?
Yeah.
Kindergarten to 6th grade?
Yeah.
Okay, so I took a shot at that one, right? So I got lucky on that one, all right. So you now represent the school that has been on the most this year on Do the Math.
Yeah.
Did you know that?
No.
Well, congratulations. You now represent that person because there are students from all different schools throughout Kern County. And Panama now has had, I think you are student number 6 out of all of the different days we've had. So Panama has had the most students on the show. Have you known any other students that have been on the show?
Yes.
Who?
Zachary.
And he was just on yesterday, correct?
Yes.
Did you happen to see yesterday's program?
Yeah.
Oh,
I saw it today.
Did he do all right? He did all right?
Yeah.
Yeah, he did all right. You know what? You're going to do all right, too. You all cool with everything?
Yeah.
All right. How is math going so far this year?
It's going good.
Is there anything that you've had any difficulty with where you're like, hey, you know what? We did this, but I didn't really kind of get it this year. Could use a little work?
I think one problem, but I don't remember it.
Okay. Well, that's probably why it's a problem, right? You don't remember that one? So maybe we'll come up with some stuff. You'd be like, oh, that's just like the thing that I was having difficulty with, all right? So are you ready to help me with the social media problem of the day?
Yeah.
All right, let's take a look at it together. So this gets sent out to all the different social media platforms we have, and then people send in their ideas on what they think the answer is. So go ahead and read that up there for me, if you would, please.
Problem of the day, solve for G. 6G equals 48.
All right, so when you see that, what do you think of? Do you have any idea what we have to do to solve that?
Times it.
All right, we have to times something, right? What do you think we're timesing or multiplying?
We're multiplying 8 because 6 times 8 is 48.
Okay, so you automatically threw the 8 out there. You automatically knew that, right? So we have to go 6 times something is equal to 48. So which one of those do you think is correct?
I think C.
You think C. Now let's take a look at A, 42. Why do you think 42 would be up there?
Probably because they divided it.
Almost. What if we did 48 minus 6? What would that be?
That would be
42. Right? Does that make sense?
Yeah.
So 42 is up there because somebody might go, I don't know what to do, I'll just subtract them and get 42, right? B is 6. Why do you think 6 would be up there?
I don't really know why it would be up there.
Okay. Cece, you have a guess as to why they would put 6 up there?
6?
I'm thinking because there's already 6 up there.
Yeah, probably.
Or somebody wouldn't know their multiplication tables and they
Right.
just think 6 times 6 is 48.
Right. Kind of same thing as the D.
Right. So yeah, so D, right? D, they've already got the constant and the variable there, so you already knew that one wasn't going to work, right?
Yeah.
So you feeling pretty good with C?
Yeah, I think.
All right, let's take a look and see if indeed it is correct. All right, there you go, Lily. First one done. See how easy that was?
Yeah.
All right. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. And yesterday we were talking about the best-selling toy in the world today is the Hot Wheels car. And they sell still an amazing amount of Hot Wheels every single second throughout the world. One of the greatest toys since the 1960s. This, even before that, hula hoops. So we're going to talk about the magic hula hooping today. And one of the things that I found interesting was they talk about the best shape to have to be able to hula hoop. So it always seemed like some people could just hula hoop better than others, but why is that? Now that is exactly true, because when I was at school, over the last couple of days, having different people try to hula hoop, some people just pick it up and it didn't matter how old they were able to just hula hoop without a problem. Others, such as myself, tried to hula hoop and it didn't work right away. And I dare say it didn't work after a couple of times either. But there are just some people that can hula hoop better than others. The shape of your body plays a key role in helping to keep the hula hoop circling your body. So a lot of people go hula hooping. You're actually not hula-ing, all right? So hula would be a motion, if you think about it, in Hawaii, right? So I can see you guys having a fun time with that. But anyway, it's more of a thrust action, let's say, that helps you to hoop instead of hula-ing. No, we're not going to do that either. With the pineapples, you got the music in the background and going. All right. So anyway, so scientists replicated some motions, and we're going to take a look at the optimal shape for hula hooping. So let's take a look at this now. So we can see that a cone-shaped body, this one right here, where the hula hoop starts off and automatically goes down. However, more of a pear shape is going to be able to retain that circular motion a little bit longer. So there is a difference in shape that is going to be able to keep the hula hoop rotating for a longer period of time. And there are people that can hula, they can move the thing up and down on their body and then go to their arms and different things like that. So before we go too much farther, we're going to come back to this in a minute, but I know we have a professional hula hooper in studio right now. So Lily, when is the last time you picked up a hula hoop before today?
I think in 4th grade.
Okay, 4th grade. So it's been a couple of years, right? So you want to give the hula hoop a try and see how it does?
Yeah.
All right. All right, so right away, you've got it, right?
Yeah.
Pretty effortless, right? And you're able to hula hoop, all right? So what are you thinking of, or how did you do that? What did you do to kind of get that started?
Like move around.
Okay, so you're just kind of going around.
Yeah.
All right, so I know that I brought in 2 different hula hoops. All right, so let's give you the other hula hoop. You can trade that out with Mac there. All right, so try that one now.
Okay.
And that one also.
Yeah.
Does one seem easier than the other?
Yeah.
Which one?
The bigger one.
Why?
Because it goes around bigger, so it bounces off.
Okay, that's a great way of explaining it, right? But the larger the hoop, the easier it is to have it circle around your body, all right? So a lot of times people that are professionals, you'll see them with these really small hoops and they can get them going on their arms and legs and waist and everything at the same time. One reason because there's not a lot of space, but they're smaller and they're able to do it a little bit easier because they're better at having that hula hoop circle on them. So you want to try the smaller one again?
Yeah.
All right, try it again. There you go, nice and easy, right? Kept that thing going. Now try the larger one again and see if indeed you do feel a big difference, or now that you've done it a few times, it might be easier. Like, I don't care what hula hoop you give me all of them. So there's a difference in your motion also, right? Because you don't have to work as much with the larger one. So nicely done, Lily. So now we're going back to the hula hoop. We've taken a look at the scientific evidence to show one shape is better than the other. Time now to look at some different shapes. So obviously a hula hoop is a circle. So these are a lot of shapes that students will see most often, probably starting in kindergarten, with a lot of the basic shapes. And then as they go through elementary school, they will become familiar with all of the different shapes. These aren't all of them, but these are the most common shapes as far as 2D geometric shapes go. So now we're going to take another look at the shapes and see if we can do something a little bit different with them. So we want to know how many diagonals there are in these different shapes. So if we have a square, and we want to draw a diagonal. So I can do one that way. There's no other vertex or corner that I can go to make a diagonal. So I only have one right there, but I can go here, and now I have two diagonals. Those are the only possible diagonals that there are with a square. Next, I have a hexagon. So I can draw one, I can draw two, I can draw three. I can't go to either of these. So I'll go to the top again. I can draw 4, I can draw 5, I can draw 6. There are no other points in which I can start a diagonal that have not already been met. So I can see that I have, did I have 6 correct? A dodecagon.
Your bottoms.
You can keep going.
Go to your
Oh.
bottoms to your sides.
There we go. I was going to say, I know something seems wrong there. I know I can go to other ones. All right. So here we go. 7, 8.
Go to
Bottom.
the next one.
Have I got them all?
No,
So
one
start
more.
there.
Yeah.
Go to your right.
There should
Oh.
be 3 coming off of each
There
one.
you go.
Now I've got them.
There you go.
Because everything has 3 coming. Okay, that's what it is. So now I've got 9. I knew the 6 was off. I'm like, I know I've done this before. It was more than 6. All right, so anyway, that's the beauty of math. So now we have a dodecagon, but I'm not going to want to draw all those out. And then you're going to get to some other shapes where you have a lot more sides. You're not going to be able to draw them all, especially when they're on a piece of paper, because they're going to be too small to draw these on. So there are formulas that you can use. So we're going to say n, which is the number of sides on the polygon. We're going to multiply that by n minus 3 and divide it by 2. So if we have the square, we know that there are 4 sides. We're going to multiply that by 4, still the number of sides, minus 3. This is 1. So 4 times 1 is 4. Divided by the 2, we can see that we have the 2 diagonals. Here we have the hexagon. So we're going to substitute 6, 6 minus 3, all divided by 2. So here we have 6 times 3, which is 18, divided by the 2, which is the 9. So once again, now we have a dodecagon, which is 12. So we're going to go 12 times 12 minus 3. This is 9. So 12 times 9. So that's going to give me 90, and 18 is going to be, 108.
He's having a day.
Divided by 2 equals 54. So that would be a lot of fun trying to draw 54 different lines inside of this. But anyway, so we can go n times n minus 3 all divided by 2. And those of you that know how to distribute, we can simply go like this. N squared minus 3n divided by 2. And that is today's Math in the News. We'll be back with more, possibly hula hooping, right after this. Continuing our look at patterns in mathematics with different numbers, strange but true, here we go. Take any number at all, subtract the sum of the digits, it will always be divided evenly by 9. Let's take a look at some examples. 736. 7 plus 3 is 10, plus 6 is 16. So we subtract 16 from 736. Will it divide evenly by 9? Indeed it will. 80 times. Try another number. 243. Add them up, they add up to 9. 243 minus 9 is 234. 234 divided by 9, 26. Works evenly. Try something where all the digits are the same. 555. It adds up to 15. Subtract the 2, we have 540 divided by 9, comes out to 60. Try a larger number. 1, 2, 3, 4. They add up to 10. Subtract them. 1224 divided by 9 is 136. Try it with any number you like. Add up the digits, subtract it. It will be divisible by 9. Strange but true. Another pattern in mathematics. And that's pretty much all it is patterns right there. In studio, we have Lily, a 6th grade student from Panama, enjoying 6th grade so far.
Yeah.
Is there anything you're looking forward to when you go to junior high school?
Joining like a band.
Oh,
like the
okay.
band.
So do you do band now? Do you play an instrument now? Or are you
No.
looking forward to doing that?
Yeah, I'm looking forward to doing that.
Is there an instrument you have kind of in mind already?
Yeah.
What is that?
Violin.
All right. Have you told your parents yet?
Yeah.
Okay. Well, that's a good thing that you told them. Okay. All right. You ready to do some math?
Yeah.
All right. Head on over to the board. So you and Cece are going to work on something that 6th graders need to know because you're going to do a lot of them when you get into junior high school. So you're going to work on an expression and evaluating the expression. All right. So
Okay, so my first question to you, do you know what the difference is between an expression and an equation?
I think.
What do you think it is?
I don't really.
Okay, so an equation has an equal sign. An expression does not have an equal sign. So we're going to do some stuff that does not necessarily have an equal sign to it. Okay, so we're not trying to make it necessarily equal something. We're just going to go ahead and simplify. So we're going to go ahead and do something like this. Let's do I have 4 plus 2n times 5 minus 7 minus 3. Have you done distribution? Have you heard of distribution before? We good with distributing? Can we distribute today, Mike?
please distribute.
I would love to do that. Let's do that. Okay. Have you done a lot with negative numbers before?
Just a few.
Have you done multiplication with negatives before?
No.
Okay, then we're just going to go ahead. Maybe we'll teach you just a little bit. All right, we'll go ahead and do that. Okay, so we're going to simplify this. We're looking good? Or are we looking? We're looking good. You like
No, that's
this?
going to be fine right there because
Okay.
you've got a variable in there and you've got plenty of negatives.
Okay. Okay. We got a lot going on. Okay. Are you panicked? Are you kind of like, this is something I've never seen before?
Yeah, I never seen this.
That's okay. We're gonna go. Have you done order of operations before?
Yes.
Okay. So then we know we can go ahead and start where with our
With
order of
the
operations.
parentheses.
Okay, my parentheses, right? So this is a really good lesson in parentheses because we always talk about let's do everything in parentheses first. So if I start here, -4, is there anything I can do inside of this parentheses?
Times it by the 3.
Okay, it's multiplication, right? There's nothing to do inside this case. This parentheses means, you just said it,
Times it.
right, to multiply, right? So we're not doing anything inside, so we're going to go ahead and hold off on that. How about this? Is there anything to do inside of this set of parentheses?
Not really.
Not really, right? Again, it means multiplication, right? Okay, then we're going to look at this set of parentheses, n minus 6. You said you've never seen this before, so I'm just going to ask you, do you think there's much I can do with an n minus 6?
I think times these two, and then it'll be minus 6n.
Okay, so we're going to go ahead and I know where you're going with that. So my question to you, can I subtract 6 from n just as it is right now? Can I get an answer for n minus 6?
No.
No, it's just n minus 6. Okay, so all of these things mean multiplication in this case. Okay, so what's my 3 times -4?
Minus -12.
Perfect, go ahead and give that up there. Okay, now let's talk about this multiplication because we're talking order of operations, so we're going to do all our multiplication first, right? So what is this? Do you know?
10n.
It is, perfect. Okay, because why?
Because 2 times 5 is 10, and you can't times n, so you just leave it
You're
there.
just going to leave it there. Okay, so now is this positive or negative?
This is positive.
So we're going to go ahead and give it that plus sign. Perfect. Okay. Now, we're going to go ahead and we'll just leave that -7 for right now because there's nothing to do with it. Now, tell me about this.
So I think we times -3 times 6, and it would be -18n.
Okay, so here's what we're talking about, and you're exactly on the right track. This is multiplication, but when we have it in parentheses, we're saying that -3 needs to multiply to everything inside the parentheses. So what's -3 times n?
-3n.
Perfect. So let's give it a -3n. Okay, now you said we're going to take, what are we multiplying here?
-3 and 6.
-3, and this is a minus sign, but it also can mean plus negative. Have you seen that before? So that -6, we can also think about it as having that as our sign of -6. So it's actually -3 times -6, which gives us?
-9?
So your 3 times 6 is?
18.
18, perfect. Negative times a negative is? It's a positive. So 2 wrongs don't make a right, but 2 negatives do make a positive, so we've got that plus 18.
All right, now hold on a second. 2 wrongs don't make a right, but 2 negatives make a positive.
Yes, they do.
So we're not saying negatives are wrong.
Well, I'm not, I was just...
All right.
Where are we going? Where are we going with this, buddy? Where are we going? Where are we going?
Negatives aren't wrong, they're just negatives.
They're not
Nothing
wrong
wrong with
numbers. They're
negative.
not wrong numbers.
Correct.
They're not wrong. So they're
All right.
they're okays and okays make
I
positives.
just wanted to throw you.
Yeah.
Keep
Okay. Yeah. Okay. So now, tell me what we've got negatives, we've got positives, and all this stuff. Are we just going to do the 12 and the 10 and the 7 and the 3 and the 18?
No,
No. Why?
because addition comes first, then subtract.
Okay. So addition and subtraction, we do it left to right at the same time. So addition and subtraction are kind of grouped together, left to right. But when I say we've got a 12 and a 10, I don't have a 10, do I? What do I have?
You have a positive
I have a 10.
n.
N.
So
These two things are going to be, right? We're going to combine what they call combining like terms, right? Okay, those are my like terms. Both of them are n's. So I have a positive 10 and I have a negative 3n, which gives me?
13n.
Okay, but I have 10 positives and I have -3.
So would it be like -13 or plus?
Nope, you're trying way too hard. What's 10 minus 3?
Oh, 7.
Perfect. So we have 7n, right? Okay, so that's going to be our 7n. Okay, so now I've got my -12 minus 7 plus 18.
These two are next, right?
Okay, go ahead. So -12 minus 7. Do we know what to do with that?
It's -5.
Okay, so I'm gonna challenge you just a little bit. There's a lot of ways to do positives and negatives. For me, I like to think about it in terms of money just because that works for me. So I think about negatives as being I owe money. Okay, I owe $12 right here. I owe $12 right here. I owe $7 right here. How much money do I owe?
You owe 19.
I owe $19. So these two things combined together, I owe $19. Now I'm going to add 18. If I'm thinking about this as owing money, what do you think positives mean?
Adding?
It means I have money, right? So I owe somebody 19 bucks. I get 18. What do I do if I'm a good person?
You subtract it.
I pay them their $18, and then what do I have left?
You have left 1.
1. Do I have 1, or do I still owe them 1?
You still owe them 1.
I still owe them 1, right? So that's going to get me what? How am I going to write that? How am I going to show it? Perfect. Okay, so let's go back through this mess. So we went ahead and combined these. So let's get our final answer. So our final answer is 7n, because that's what we got when we combined those like terms. Oh, remember, we combined like terms here. You told me we couldn't combine all this stuff, right?
Oh, yeah.
So it's 7n.
So it'll be 1n.
So we're gonna go ahead and write it right here. So just write 7n minus 1, because that's what we got when we combined these like terms. And then when we did all of this, we got to here. So we get to here. Now, is there anything we can simplify from there? 7n minus 1. Or are we done?
No,
We're done?
I don't really know.
We're done, because again, just
Oh, yeah.
like you did with all the rest of these, you said that n, since we don't know what it is, we can't do anything with it. This is our answer. We have nothing left to do. 7n minus 1 is it. Nicely done.
And I'm glad, Lily, you've done one of those problems with CC right there, because you are going to get countless numbers of those next year. And hopefully you'll go, oh, that's right. I remember CC doing this with me, and this is not going to be a problem now. Because I dare say I give you another one later on, you're going to be able to go right through it a little bit easier now, right?
Yeah.
Yeah.
So for your great effort so far today. You've got yourself a pass to any CSCB athletic event, courtesy of CSCB Athletics. And if you go to a basketball game, they have the band there. So you can see kind of a band at a college. All right,
Except she
there
wants
you go.
to play the violin. Right.
That's right. Well, you know what? It's all music, though, right? You must appreciate all music, even if you are going to play symphonic music. That's lovely also. 636-4357 is the number. We'll be back with more right after this.
Is NASA aware of any Earth-threatening asteroids? No, there is no asteroid that we know of that is concerning in terms of impact hazard. Now, we know that asteroid impacts have happened in the past and can certainly happen in the future. But we should keep in mind that those are rare events. An asteroid impact that could cause serious regional damage only happens every few thousand years or longer. Still, it's a good idea to protect us against that possibility, and the rule of the game is find asteroids before they find us. And that's why, for over 20 years, NASA has been funding search programs to observe the sky pretty much every single night to find and track asteroids. And we've been doing a pretty good job at that. So far, we've discovered more than 1 million asteroids, including 95% of the asteroids that are greater than 1 kilometer and that could come close to the Earth. Once we discover an asteroid, we project its motion into the future to assess the possibility of an impact with Earth. We have a scale called Torino scale that helps us rank the risk coming from each asteroid. It goes from 0, which is lowest risk, to 10, which is highest risk. The good news is that for all the asteroids that we've discovered so far, the Torino scale is 0, so lowest risk for the next 100 years. So, is NASA aware of any Earth-threatening asteroids? No, but we will keep searching the skies just in case.
No, NASA is not mining asteroids. The technologies for mining asteroids are not well developed. We actually can't really mine asteroids yet, although many people are working on it, private sector, people outside of NASA. What NASA is doing is fundamental science, research missions that go out to asteroids to try to understand more about them, and they will help any eventual future efforts to mine asteroids. And our NASA Psyche mission is an example of one of these missions. We are going to visit an asteroid that we think is made largely of metal, but from those pure science missions comes the information that maybe in the distant future, humans will be able to mine asteroids and save some of the resources on Earth. So is NASA mining asteroids? No, but NASA is doing the fundamental science of sending missions to asteroids to understand what they're made of.
And in studio, we have Julie again with us. How are you today?
I'm great. How are you?
I'm excellent. Even better now that you're here, because I love finding out all about when the students are young, and sometimes even before they're students.
Well,
the math that they can learn. They're always
Right,
students,
they're
but
always
I mean in school,
Yeah.
like that. So
Preschool, TK, transitional kindergarten,
Right.
all of that, yeah.
And-
They're learning.
right, that's what I'm saying, because it doesn't matter what age, they're always
Right,
learning.
right.
So we're talking about shapes today.
We are.
All right. What would you bring with you? I know.
Well,
I've seen those.
I brought a lot of things, but I brought some videos too.
Okay.
Because in early education, just like what you were talking about earlier, they learn about those one-dimensional shapes.
Right.
Typically, you know, the square, the circle, the rectangle. But we don't want to forget about the three-dimensional shapes too that we'll talk about in a little while. And of course, you know me, I always have to bring my books.
Right.
Because we want to talk about shapes everywhere, not just on a piece of paper, but shapes are everywhere
Everyday
in the
objects that
environment.
they see all over the place.
Exactly.
Right.
Exactly.
Because even something like this table, this desktop, I think that's like, I mean, it's not mathematical, but like a kidney.
Exactly.
Right? So
There's
yeah, I mean,
a name
there's-
for it.
everything's got a name as far as the shape that goes with it.
Right, and when we talk about shapes in early education, we also, and you talk about geometry, so it's shapes, but it's also about space and those positional language that we want children to talk about. So if they're stacking blocks, one on top of the other, or the triangles on top, the rectangles next to the square.
Right.
So those are kind of some of the things that we also do in early education is exposure to the language.
Right,
as
next
well.
to, before, after, between, things like that. So I know
Right.
that you said you had some videos, so
I
we're ready to
do.
take a look at the first
Yeah.
one?
What shape is this?
Triangle.
How do we know this is a triangle?
Because I have 3 sides.
3 sides. Good job, Winnie. What shape is this shape?
A square. The
shape
fourth
is-
side.
It has 4 sides that are all the same. What shape is, well, we did that one. What shape is this shape?
An oval.
An oval, it looks like a circle that's stretched out long. A continuous line that goes around. What shape is this? How do you know it's a rectangle?
Because it has 4 sides. Because it has 2 long sides and 2 short sides.
It does. 2 long sides and 2 short sides.
And I think it's important that they're using their hands to describe the shape and talk about and add to that vocabulary also.
Right, so you want them to know that the square is 4 sides. And she said the same, but you could use equal as well. Again, bringing in that math language that we want to expose children to.
Right.
What was key in that too is she was asking the children, how do you know?
Right.
How do you know? Because we want children to
Instead of
think.
just guessing and going, oh yeah, I guessed right, but I have no idea why that's it.
Right.
Because I heard the word.
Exactly. So you want them to talk about how they know. They need to think about what's the attributes of that shape. She could have also talked about the points or the
Right.
vertex. Again, exposing that language and getting children to think about why.
And I think another also thing very beneficial is having the students in a group instead of just focusing on one student at a time. So they can feed off of each other and help each other at the same time.
And what they were doing there, which we didn't see, and of course it's a very play-based environment, they were having fun, but then they started taking the shapes that she had and they were pasting them on paper on the table, making whatever they wanted to make. So now you've taken the shapes and you've created a house.
I was going to say,
Or
see
a
how creative they
robot.
are and what they're thinking of and how they want to use those.
Exactly. So it's not just, okay, let's talk about the shapes today, but now let's use the shapes and create something that they know about in their environment.
Let's take a look at the next one.
Perfect.
And how do you know it's a square?
Because it has 4 sides.
Because it has 4 equal sides, correct. Okay, can you throw it into the correct shape on the floor? You can walk over there. Good job. Okay, come back. Now what's that next shape you got? Do you know what it is? Okay, tell your friends. And how do you know it's a triangle?
Because it has 3 sides.
Because it has 3 sides. Good job.
And once again, the key, how do you know it is?
How do you
right?
know?
And then having them classify the shapes also.
Right, but and with this particular video, it's doing it outside, and then matching the shape. So they had to go find the circle that was drawn on the ground to go throw the circle into, or the triangle. And then again, telling your friend. So not only are you learning from the teacher helping you a little bit to tell you what it is, now I'm going to repeat it.
Right.
Okay.
Because when you teach others, you're reinforcing it in
Ex-
yourself also. Because that's how
absolutely.
many more times you're learning it by helping somebody else.
Right, exactly.
All right. Video number 3.
You got it.
All right. All right, so here we can see that they've got tiles, magnetic ones, right? So magnet tiles, I believe they are, and they're building. Were they instructed on something to build, or?
No, actually, they had the magnetic tiles. They can choose to build whatever they want. But when they were, if you'd been there and listening to what they were doing, they're talking about what they were building and putting the squares together to make the side of this structure. I think it was a castle is what
Okay.
they were looking at.
A colorful
And then-
castle.
Yeah, very colorful. And then putting the triangles on top to make the top of the castle. So again, building with the different shapes, seeing what they could make with them, taking, in some instances, they were taking 2 triangles and putting them together, and
To make
then
the square.
they had a
Right.
square. Exactly.
So I think it's important also to use the different materials, even though you're using the same shapes, but different actual materials for them to use and feel and manipulate and build with.
Right, and to also point out the different shapes in the classroom. You know, and that was a particular classroom, but you can do the same thing at home or anywhere.
Anywhere.
Is because shapes are all around us, and then talk about where are those shapes.
Right.
Well, it's on
And
the wall.
here's some of the 3D shapes that you brought in, and a lot of classrooms have these wooden sets, let's say.
They do, and so what we want to do with the wooden shapes is expose them to the three-dimensional, of
Right.
course. So, but what's the name of this? Is this still a square?
Right, see, so now they'll
Or
have
is
to learn
it
that it's a cube.
Cube,
Right.
exactly. So I brought a graphic, I think, that we can. Oh, you want me over there? If you want to. Okay, so this is something that we use in trainings a lot. So we've got the 3D shapes, and then the teachers have to guess what they are.
Okay.
And it's interesting because a lot of them forget, they don't know. But again, putting the the new language with this shape.
And then I can see that you brought other materials so you can see where they are in everyday life. So it's something
Exactly.
they'd be familiar with, and they'll go, oh, I see that there's a circle on top, but that is a cylinder.
It's a cylinder. And so we encourage parents, what do you have at home that you can talk about shapes with? You know, one of the things that we ask parents to do, just go around and count the windows in your house. Are they like a square? Are they like a rectangle? Your doors. But there's other things in your environment too. I mean, these are kind of neat little boxes. Gourmet beans. I've seen these too in hotels where they
Right.
put things in
Put
them.
things in, right.
Yeah. And so what is this? It is a
Triangular prism.
triangular prism. You were right.
I got lucky on that.
But there's all kinds of things. And the other thing that is important to understand is that when we talk about shapes, we're very precise. And we encourage teachers to, if children like their sandwiches cut in a triangle, and so we encourage them to say, it's like a triangle. It's like a triangle, and then explain why.
And I'm glad that the books are here, so once again, we can kind of wrap this up, showing that the shapes and literacy, mathematics, all of it goes together. Art also at the same time. There's so many things that are involved in all of this when discussing shapes. You can take it forever and ever and ever. It just
You
keeps on
can.
going. You can do it all day long. Kids won't even realize that you're doing shapes all the time.
You know, and they're having fun and they're learning new language. And, you know, like this one is one of my favorite ones, the secret birthday message, because it's actually an opportunity for teachers to do an extended activity where they're looking for that birthday message, and they can use shapes in the classroom
All
to
right.
do kind of a
Well,
hunt.
Julie, once again, thank you for coming in this afternoon, and always a pleasure to have you in
Thank
studio
you.
with us. And I saw you brought that little tiny hula hoop right there.
I did.
That's not going to work. That could work on the finger right there. But you know what? We'll be back with more right after this. Julie and I are going to go try the hula hoop.
There we go.
somewhere.
Let's do it.
Where did human life begin? How did world cultures evolve? What impact have natural disasters had on people and civilization? Anthropologists and archaeologists explore these types of questions to learn about human history and bring insight to current issues. Anthropologists and archaeologists study the cultures, languages, archaeological remains, and physical characteristics of people across the world and through time. Typically, they conduct research to answer questions and test hypotheses about human behavior and culture. Data collection and analysis form the core of their work. Their projects may result in published research or reports on the impact of potential land use policies, healthcare programs, or even products. Most anthropologists work either in research organizations, for government, or at consulting firms. Archaeologists focus on physical findings. They analyze human remains and artifacts such as tools, pottery, cave paintings, and ruins. They also preserve artifacts and interpret their significance through their knowledge of related historical information. Archaeologists work in museums, at historical sites, and for government agencies. They also work for cultural resource management firms that identify and preserve archaeological sites and ensure compliance with regulations. Anthropologists and archaeologists need a master's degree or PhD in anthropology or archaeology. Fieldwork experience, either in the United States or abroad, is important for both disciplines. Bachelor's degree holders may find work as assistants or field workers.
All right, so Lily, do you remember when you were in younger grades working with shapes like that and learning all about those things?
Yeah, I believe so.
Okay, and now you're doing 3D shapes and things like that, and pretty soon, if you haven't done it yet, probably doing circumference, area, volume of 3D
Surface
objects
area.
and things like that, yeah.
Yeah.
More fun stuff. But you know what? We're going to continue with the fun right now. You've got one more expression to evaluate.
All right, let's go ahead and do it. So we're looking at our parentheses first. I know you know to do that first. What do we have in parentheses we can actually do?
We can actually do this one.
All right, so we've got 4 minus 5 giving us?
That would be -1.
Fabulous, I like it. So go ahead and then, do you like to rewrite the entire thing, or are we ready to go on and just say, we can just call that -1 and we'll just go ahead and move forward with that?
Yeah.
Okay, all right, so go ahead.
I think.
So what's the next step we're doing?
We're doing this step where.
So it's called distribution, but it's actually what? It's multiplication, right? We're multiplying. So if we're going to do multiplication left to right, we've got to start here. 6
Okay.
times -1 gives us?
-6.
Perfect. So let's go ahead and write down our -6. Okay, and now we'll do the distribution here.
I think it might be 10n.
Okay,
Or -10n.
so remember, we're going to do, we said the 2 needs to be multiplied to everything inside the parentheses. The first thing is the 2 being multiplied to the n, which is?
2n.
Okay, and is it positive or negative?
Positive.
So we're going to do plus 2n. And then we're going to distribute again. 2 times -5 gives us?
-10.
Perfect. Okay, I like it. And then we've just got that plus 3 hanging off that back end. So let's go ahead and write out that plus 3, sorry. Okay, next step is going to be what?
I think going this way or that way.
You're right. So we're going to do, we've just got addition and subtraction. We're going to go from left to right. So my question is, can the -6 be combined or be added to the 2n?
I think it could be combined.
Okay, so remember, like terms tell us that since we don't know what this n is, we have to just keep it alone. So we're just going to go ahead and leave that as 2n. Okay, so now we're going to do the rest of it. So -6 minus 10
is -4.
Okay, so again, if we talk about negatives being we owe money and we owe money, I owe $6, I owe $10, I
owe $4.
I owe 6 to somebody. I owe 10 more.
So you owe -16.
There we go. We owe -16. I owe $16, and then we've got plus 3. So go ahead and do the plus 3.
So it would be 19.
Okay, so remember, I'm going to say I owe 16 and I have 3. So if I'm nice, if I'm doing what I'm supposed to do, if I have $3, what should I do?
You should give it and you'll have -13.
Perfect. So my final answer is going to be, let's not forget this. Fantastic.
There you go, nicely done. So a little easier than the previous one, right?
Yeah.
So that's the whole thing, because when you first did it today, it was kind of a challenge, right?
Yeah.
But talking through it, learning it a little bit, now you did it again, and you got a little bit more of it, a little bit easier. And guess what's going to happen when you do it again?
It'll be more easier.
Right, it'll be a little bit easier the next time, right? But the key is that you have to practice at it and keep going, right?
Yeah.
Because you haven't started violin yet, right? But you're going to, right? Do you think you're going to be able to pick it up and just play it?
No.
No, right? You're going to have to practice it, right? Same thing with mathematics. So I'm glad you were able to get through that and you were able to finish that problem on your own right there. Nicely done. We'll be back with more right after this.
Our world is changing, and there's a need for leaders who can help create a more sustainable and just society. Cal Poly Humboldt is where those leaders are made. As a third polytechnic in the state and the first in Northern California, Humboldt is a leader in natural resources and science with a solid foundation in liberal arts. Our strengths are grounded in teaching that's hands-on and within reach.
I wanted to study environmental science, and what better place to do that than in the Pacific Northwest, where I have like the ocean on one side and then the redwood forest on the other.
It's a living lab that informs how and why we teach. One where students and faculty grapple with today's most pressing environmental and social challenges to be part of the solution.
So we got to get off fossil fuel as we also adapt and become resilient. This project is doing both of those things in a really big and bold way. So I'm going to brag about it, yeah.
That project, developed for the Humboldt County Airport, is California's first 100% renewable multi-customer microgrid. This is one example of groundbreaking microgrids that were designed by faculty and students at the Schatz Energy Research Center at Cal Poly Humboldt. The system generates revenue and emergency power for the airport and neighboring Coast Guard station, serving as a model for energy resilience throughout the world. Amid a statewide kelp collapse, Cal Poly Humboldt is at the forefront of California aquaculture. The university launched the state's first ever open water commercial seaweed farm, a project that stands to kickstart an industry that's good for the environment and the state economy.
It's still relatively new here in California, and so we're excited to be the first pilot farm.
The farm in Humboldt Bay creates habitat while capturing carbon and improving water quality. At the same time, students actually create a roadmap for the future of aquaculture in California. What if the same fiber optic cable that delivers the internet could also help save lives? That's the thinking behind cutting-edge earthquake technology being tested by our geologists and students in the most seismically active region in the continental U.S.
We spent 3 days implanting in the ground 48 mini seismographs that we refer to as nodes along the fiber optic cable here in Arcata.
The experiment provides valuable insights to better understand and monitor earthquakes, which could improve early warning systems.
We can try to warn people before these big seismic episodes are going to happen, and people don't have to get hurt. What would it be like to be part of that? You know, we can do that.
It's going to be the biggest dam removal effort in the history of the world.
Over the next several years, 4 long-standing dams on the Klamath River will be removed. The project offers Cal Poly Humboldt faculty and students a historic opportunity to examine everything from bat diversity to survival rates of Chinook salmon. This research will help gauge the river's health after the dams come down, and it sets the stage for a better understanding of similarly affected watersheds worldwide. One professor has taken students deep into the heart of the river to learn directly from teams working on the Klamath's renewal and from the tribal communities who are profoundly impacted by the river's health.
One thing that's been really important is partnering with the tribes. So we're really trying to center the voices of Native people by meeting with the different tribes along the way.
Faculty show students the value of learning from multiple perspectives, building a more nuanced understanding of the world that students will use in their careers and for the rest of their lives.
I've been here, I've been to other places, but this institution, the university, has the best professors because of their focus on how they help students to achieve their professional goals.
This community here has brought me my lifelong friends, has brought me lifelong mentors, and I really couldn't have been more thankful to have met everyone here at Humboldt.
Cal Poly Humboldt. It's a place where students dream big and boldly. They dream of a better future for our planet and for people. And we're preparing them to make those dreams a reality through education, advocacy, and research. Because what we do here has a long and lasting impact in California and around the world.
My dream is to ultimately help others, and this community has shown me so much love, and I want to bring that love to the rest of the world.
A beautiful campus up there in Humboldt. Once again, 636-4357 is that phone number. Before we get working with Lily again, I want to send out a special thank you to all of our sponsors on Do the Math, especially Chevron, a major sponsor of Do the Math, and we want to give a special shout out to Chevron for their generosity over the many years, all 23 years of Do the Math, and just a great partner to have with Chevron over these many years. So once again, thank you to all of our sponsors and to Chevron especially today. Lily is a 6th grade student from Panama Elementary, and you've been doing expressions, and this doesn't look like anything like that, does it?
No.
All right, so what you need to do is you need to figure out the size of that glass on the far right based on the information you're given in the first 2 columns of glasses there. So talk to Cece about what you would like to do, and I believe you're all ready to annotate and write on
Yeah,
that.
you can write on there if you want to, if there's things that you would like.
So anything you'd like to write, but talk to Cece about how you'd like to approach this problem and start it.
What do you think?
So I'm thinking this might be like a 3 or 6 centimeters.
Okay, so you want to kind of guess at it a little bit and see what happens?
Yeah.
Okay, so we can start there for sure. So grab a pen and we'll see what we want to do there. Okay, so go ahead and show me what you're thinking.
So I'm thinking that this right here could be 16.
Okay.
And this could be like 3.
Okay, so if that's 16 and 3, then what would it look like if I did it here?
This would be 19. It would be 19 plus 3 would be, wait, 19 plus 3 would be.
So go ahead and mark that up there so you can kind of start to see it, so we can see it graphically what you're talking about. So what's 19? Where's the 19?
19 is right here.
Okay, all right. And then you're talking about each of the sections being 3 maybe, so.
Yeah, like this might be 3, these.
Okay, so does that add up to give us 34?
We'll see. So 19 plus 3 right here is, would be 22.
Okay.
And then 22 plus another 3 would be 25.
Okay.
Then plus another 3 would be 28, so that couldn't be it.
Right. Now, did we need to add the 3 times? What would it be another way we could have done that?
Times.
Yeah, so we could have just done it by added the 9. Okay, and that's all right. So we're not there. So, okay, that one didn't work out so well. We didn't get to 34. So what do you want to do next? Do you want to, oh, maybe I shouldn't have erased that, but that's okay. So what do you want to try next time?
I want to try next time that this one could be probably 18 or 17.
Okay, so you think it needs to be bigger. So you think that this bottom glass needs to be bigger and this one needs to be smaller. Okay, so when we got 28, we needed to get to 34. Was it under or over?
It was under.
Under. So we need to get to 34. So we need to be adding what? We need to be adding higher numbers or lower numbers?
Higher.
Okay, so instead of this being 3, what do you think it might be?
It might be, since we got to 28.
What's going through your head right now? I see you kind of counting things. What are you thinking?
I'm thinking about like 28 if I subtract 34 and then I figure out how much is there.
Oh, I like it. Okay, so 34 minus 28 is going to give us what? Okay, so we needed 6 more. Okay, we needed 6 more distributed, well, we're going to go back to that word, distributed between how many glasses? Did we have
4.
6? Okay, so you're saying 4. 1, 2, 3, 4. Are you sure it's 4?
No, I was just saying
Try
that.
it. Let's see what happens.
Okay. So if we're going to distribute the 6 across 4 glasses, how would we do that?
19 times 4, right?
What we're talking about, because this height is the same as this height, right? So we know up to here is how tall?
Oh, so 19.
I like that. Okay. So if this is already 19, and you said we needed to have 6 more, we only have 3 glasses above that. So we have 6 that we need to have with 3 glasses. So each glass gets how much more?
2.
2. Okay. What did you originally say it was supposed to be? You thought it was going to be?
4.
Okay. So what do you want to try this time?
2 because 6, you can break it up into 2s because 2 times 3 is 6.
Okay, so you can definitely do that. But originally, what did you tell me these glasses heights were? What did you tell me?
4.
The original problem we did, we probably shouldn't have erased it so fast.
They were 3s.
They were 3s. So if we're going to give it 2 more, what would they be?
It would probably be lower than 28.
So I think you're misunderstanding my question. So if they were originally 3, and we know we need it to be 2 more, how tall will each of these glasses be?
5.
Okay, so why don't we try that?
So 19 plus 5 plus 5 plus 5. That's 15, so 19 plus 5 is 34. And that's the answer.
Yeah. So you did exactly what you should do. Guess and check will work every time. You can go ahead and you can do some guesses, and then from there you can figure out how to fluctuate through there.
Right. So the original question is we need to find out what size the glass is all by itself.
Oh, that's true. That's true. Okay.
So if each of those tops is 5.
All right.
There you go.
So it's 14.
There you go.
And then just put the cm for centimeters at the end of it. Perfect. Nicely done. Come on back over here, girls.
Excellent job.
All right. So that was a great way to do it. Some students look at it and they go, the whole thing is 34. I know there's 19, so I know I need 15. And there's 15 divided by the 3 glasses, so I know that each of those is going to be 5. So there's a lot of different ways to do every single type of math problem. So did you learn a little something today?
Yeah.
Good. I'm glad you did. Did you have a little bit of fun today?
Yeah.
That's the most important thing right there. You are now an ambassador for Do the Math. Do you know what that means?
No.
All right. So you are now, it's like being an employee of Do the Math. So you received your uniform today, right?
Yeah.
Remember your t-shirt, right?
Yeah.
So you'll be receiving that, and that means that you have to wear your shirt every day to school. Not every single day, but every once in a while wear the Do the Math shirt to school. And kids are going to go, hey, what's up with that Do the Math? And you can tell them about Do the Math. Sound good?
Yeah.
All right. You've also received some other great gifts from some of our sponsors, and are you familiar with this?
A Rubik's Cube?
A Rubik's Cube. You know how to do these pretty well?
Yeah.
Yeah? I'm sure you know how to do it better than I do. I can assure you of that. But this is an exclusive Do the Math Rubik's Cube. All right? So it's going to be a little trickier than other ones. Do you think I'm just making that up?
No.
No, well, yeah, that's right. It's a little bit trickier. But anyway, we have a lot of events coming up all throughout Kern County and Bakersfield. This weekend, coming up Saturday the 18th at the Buena Vista Museum, talking about mining in Kern County. So this is going to be right in downtown Bakersfield on Chester Avenue. The Buena Vista Museum's been a friend to Do the Math for many, many years. They always bring in a lot of artifacts, talk to us about different things and the science and mathematics behind all of those things. This, if you've wondered about the history of Kern County, mining, anything like that at all, or you just want to go visit the museum, this is a perfect opportunity. They've got a great event coming up. It's this Saturday, January 18th. You can go to our social media. You'll be able to find stuff on there. And once again, it's at 1:30 in the afternoon this Saturday on Chester, the Buena Vista Museum. Learn about mining. Lily, you did some excellent work today. I want to thank you for coming in. And once again, wrap up that Rubik's Cubes for us, all right? Sound good? All right. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.